In this section, we're going to focus on dilation for cube roots. Now, first we're going to do a little review, so that way you can see the rules for dilation. And as I stated before, once you understand the rules as what we did for absolute value and quadratic, it will be exactly the same rules for square root function. Now, at the very top is a little reminder of like we have a vertical dilation and a horizontal dilation. So for vertical, it's when the number outside the function is more than 1, vertical stretch. It's when the outside number is less than 1, and again it has to be positive, then it's going to be a vertical compress. Now for horizontal is when the number is inside a function. So when the number is inside and it's less than 1, we're going to classify as horizontal stretch. And then if the inside number is greater than 1, then you're going to classify it as horizontal compress. But don't forget, for horizontal dilation, you always have to write the reciprocal of that number when you're going from equation to identifying transformation, or going from identifying given transformation, when you're given transformation and you're writing out the function or writing out the equation, you always have to write the reciprocal when it comes to horizontal dilation. Vertical stays the same. So let's take a look at example 11. So I have two functions, h of x, where it's written in absolute value, and g of x, where it's written in quadratic, x squared. Now both of them, they both have 3 over 8, which is outside. So since it's outside, it's going to be a vertical. So the 3, which is the top number, since it's less than the 8, the bottom number. So since top is less than bottom, that means that the number is less than 1. Therefore, it's going to be a vertical compress by 3 over 8. Vertical, since the number is outside the function, outside the absolute value, outside the parenthesis, and since it's less than 1, it's vertical compressed. Then we're going to say vertical compressed by 3 over 8. So moving on to example 12. So here we're just going to focus on 5 over 2. Don't worry about the minus 4. We're only going to, since we're doing dilation, we're going to worry about the number that's inside and in front of x. So I have two functions, n of x and p of x. N of x is in absolute value form, and p of x is in quadratic form. But they both have 5 over 2 inside the absolute value line and the outer parenthesis, and they're both in front of x. So that's the number we're going to focus for this dilation for this example. So since it's inside and in front of x, it's going to be a horizontal dilation. So let's take a closer look at the number. Since the top number, which is 5, is greater than 2, the bottom, meaning that if the top is greater than the bottom, that means our number is greater than 1. So since our number is greater than 1 for horizontal, this will be classified as horizontal compressed. So we're going to write horizontal compressed, and of course you have to write the reciprocal of a number. So we're going to say horizontal compressed by 2 over 5. So that's all you have to do for identifying dilation when you're given the function. Since we're doing dilation, we're not going to worry about the minus 4. Moving on to example 13, we have a of x equals to 2/3 times the square root of x, or 2/3 square root of x. So here you can clearly see that the 2/3 is outside, so it's going to be a vertical. Looking closely, we see that the top number is less than the bottom number. So since the numerator is less than the denominator, it's going to be less than 1. So this one will be a vertical compressed by 2 over 3. Vertical for being outside, compressed since it's less than 1, and then saying by 2 over 3. Moving on to example 14, we have b of x equals to 7 over 4 square root of x, or 7 over 4 times square root of x. Now, since it's outside the square root, this is also going to be classified as vertical. Looking closely at the fraction, we see that the numerator is greater than the denominator. So if the top is greater than the bottom, then that means that the number is more than 1. So this will be classified as vertical stretch by 7 over 4. So vertical for being outside, stretch for having our fraction more than 1 by 7 over 4. Moving on to example 15. Here, we see that the 1 over 6 is inside and in front of the x, so this is going to be a horizontal dilation. So looking closely at the number, we see that the numerator is less than the denominator. So since the top number is less than the bottom number, then our fraction is less than 1. So since it's less than 1, that means that this will be classified as horizontal stretch by 6 over 1. And again, the reason I said 6 over 1 is because you have to write the reciprocal number for horizontal dilation. So again, horizontal stretch by 6 over 1. But whenever you have a fraction like this, you always have to simplify it. So 6 over 1 is 6. So that's why our final answer will be horizontal stretch by 6. So again, you cannot leave as horizontal stretch by 6 over 1. You do have to simplify, meaning horizontal stretch by 6 is our final answer for example 15. Moving on to example 16, we have h of x equals the square root of 5x. So we see that the 5 is inside the square root and it's in front of x. So this one will be classified as horizontal. Since we can clearly see that 5 is greater than 1, so that means this will be classified as horizontal compressed, and then we have to do reciprocal. So if it's 5, then the reciprocal of 5 is 1 over 5. So horizontal compressed by 1 over 5. Now, to clearly see that, to find the reciprocal of a whole number, you just simply convert the whole number into a fraction, and then by doing the reciprocal, you're just going to flip the fraction. That's how we get 1 over 5.